Okay, so now we're going to build on that first task, and we're going to look at some further equations that require a change of base. However, before we do that, we're just going to do a quick recap of solving a linear equation. If we remind ourselves of this first, it's going to be much quicker for you to solve the other ones, because this is a large part of it. So we'll just do a quick recap of this in case we need it. So when we're solving a linear equation like so, there's a few ways we can do it, but in general, we'll go through a formal one. The first thing that we're going to do, we're going to have a look at what we've got here. And if we have a bracket, unless that left-hand side is divisible by 2, we're probably going to expand that bracket first. Okay, expanding that bracket gives us 2x take away 18. Okay. When we're at this point, we need to rearrange this equation so that all of the x's, we've got 4 here and 2 here, are on the same side. So as a general rule, I always suggest that you choose to adjust the smaller one or the lowest one. So if one's negative, you choose the negative. So we're always looking for the lowest. The lowest here is 2x. So I'm going to take away that 2x, or do the inverse always. And in this case, take away that 2x from both sides. Okay, that leaves us on the left-hand side, 4x minus 2x leaves us with just 2x, and the rest will stay the same. Okay, then we've got a nice simple linear equation that we can solve. Take away 7 from both sides to give us 2x is negative 25, and then divide by 2 just to finish that off. Okay. If you get a fractional answer, please leave them as a fraction. It's much more useful for you going forwards. So I'll expect to see yours as fractions instead of like negative 12.5. Okay. So that recap now will allow us to move into example 2 quite nicely. Okay, and this is what you're going to have a go at in a moment. So here we still have an equation, and still on the left-hand side, it's expressed as a base with an exponent. However, so is the right-hand side this time. Okay? But those bases, they're still not the same base. So we need to make them the same base. So we're going to aim for the smaller one. So a smaller base is the left-hand side, which is 2. So I'm going to change the base on the right-hand side to be 2 as well. But obviously, if I just put it as 2, I've changed the value. So I need to find an exponent, which is going to leave me having not actually altered the value of this equation. So I went from 8, and I changed 8 to base 2 by turning 8 into 2 cubed. Okay. And that's where, again, your quick recall of square numbers, cube numbers, and roots is really, really useful here. Okay. Also notice how the exponent of 3 is placed outside a bracket now of 4x minus 9. Okay. That's because that exponent needs to be multiplied by the entire previous exponent. Okay. And then from here, just like before, because our bases are now the same, we can remove them. If the bases are the same, then it must mean that our exponents are the same as well. Okay. So then we can go ahead and solve, just like we did on the example 1 on the left-hand side. We just have a linear equation left to solve now. Okay. Smallest x is 3x, so I'm going to take away 3x from both sides. Okay. Then I'm going to add 27 to both sides. And then I'm going to divide by 9. To leave us with x is 25 over 9. Can't simplify that fraction, so we will leave it there. So that's example 2, and that's what I'd like you to have a go at now. So on the next slide is 4 questions I'd like you to do. Feel free to watch these examples again. Write these 4 questions, oh, not that one, those 4 questions out in your books and have a go at those for me, please. Then come back to the video, you can mark them, take a picture, and then upload that to the Google Classroom. Let's go. Okay, if you come back for the answers, they should all be there. Okay, so mark those, make any adjustments where you need to, and upload that to the Google Classroom. See you next time.